Welcome everyone. Myself Riya from CSE Data Science Department, pursuing my BE from Sri Venkateswara College of Engineering. Today, I'll be giving a presentation on randomized block design. What is blocking? Blocking, it is a technique used in randomized block experiment to sort experimental units into homogeneous groups called blocks. The goal of blocking is to create blocks such that dependent variable scores are more similar within blocks than across blocks. What is a blocking variable? In a randomized block experiment, a good blocking variable has four distinguishing characteristics. It is included as a factor in the experiment. It is not of primary interest to the experimenter. It affects the dependent variable. It is unrelated to independent variables in the experiment. A blocking variable, it is a potential nuisance variable, a source of undesired variation in the dependent variable. By explicitly including a blocking variable in an experiment, the experimenter can tease out nuisance effect and more clearly test treatment effects of interest. What is randomized block design? In RBD, materials are assigned to homogeneous subgroups, which is named a block. It comes in the category of single factor design. The analysis is easy but becomes complicated when a missing plot technique is required. In the replication category, RBD differs from treatment to treatment. The concept of blocking dates back to the early 20th century with statisticians like Ronald A. Fisher. The randomized block design is perhaps the most commonly encountered design. The characteristics. Randomized block design is an experimental design that ensures that a blocking variable is included as a factor in the experiment. The blocking variable is not of primary interest to the experimenter. The blocking variable affects the dependent variable. The blocking variable is unrelated to independent variables in the experiment. Treatments are randomized within a block. Few more characteristics are all treatments are in one block. There is one replicate per block treatment. Each block is a mini experiment since we compare treatments within each block. The design reduces variability of estimators for treatment means. The design improves power for t-tests and f-tests. The design results in narrow confidence intervals. The advantages are it provides complete flexibility. It can have any number of treatments and blocks, generally more precise than completely randomized design. Some treatments may be replicated more times than the others. Missing plots are easily estimated. Whole treatments or entire replicates may be deleted from the analysis. The disadvantages are it is not suitable for a large number of treatments because blocks become too large and heterogeneous. It is not suitable when there is considerable variability within blocks because it increases the error term and reduces the power of the test. It is not suitable when there is an interaction between the block and treatment effects because it violates the assumption of the analysis and confounds the treatment effect. It is more complicated to analyze when there are missing plots or unequal replications because it requires special techniques or adjustments. This is a small example for randomized block design, where the students are homogeneous groups with exception of semester. Next, randomized complete block design. The key assumptions are it is also known as the two-way ANOVA without interaction. The main assumption in the analysis is that the effect of each level of the treatment factor is the same for each level of the blocking factor. Randomization procedure. Each replicate is randomized separately. Each treatment has the same probability of being assigned to a given experimental unit within a replicate. Each treatment must appear at least once per replicate. Advantages of randomized complete block design. The estimation of missing plots is easy. Valid comparison can be made if the experimental error is heterogeneous. Some of the treatments could be replicated more time as compared to others. There is no restriction on the number of treatments. The disadvantages of randomized complete block designs is, in case of missing data, RCBD is not that much efficient. In case of large variation between experimental units within a block, a large error term could be its results. Thank you. That's all with my presentation. Do like, share, and subscribe.